integral e to the 5x cosine 4x dx. Okay, so this problem doesn't matter which one you take u and which one you take dv. If you have algebraic function, then we take that one as u because derivative will be reducing. Exponential and trig functions will not reduce. Exponential stays as it is, and cosine goes to sine, sine goes to cosine, so they are back and forth. So what do you do? First you say u equals, say, e to the 5x and dv equals cosine 4x dx. So then du will be 5 e to the 5x, you know that, and your v will be 1 over 4 sine 4x. So then this looks like u dv, so uv minus integral v du. Our u is e to the 5x, v is 1/4 sine 4x minus 1/4 sine 4x, and then du is 5 e to the 5x. I'm now writing 1/4 e to the 5x sine 4x minus 5 over 4 e to the 5x sine 4x dx. So now what happens, my problem again going with integration by parts. Look at here, so it has come out with integration by parts. Again I'll say u equals e to the 5x, so then du will be 5 e to the 5x, and my dv is sine 4x dx. So then v will be negative 1/4 cosine 4x. You understand this, right? Because I'm just taking simple integral. So then that one is again going uv method. So we have 1/4 e to the 5x sine 4x minus 5 over 4, and this integral is again giving me uv minus integral v du. It's a new integration by parts form. 1/4 e to the 5x sine 4x minus 5 over 4. Now you have uv here. So u is e to the 5x, and your v is negative 1/4 cosine 4x, and then negative negative will be positive 5 over 4 integral. So let me go with the shortcut and verify this one, then I'll come back, because this is coming like a loop. It will go into a loop. Look at here, e to the 5x, that I can see immediately in here, and that's the reason I like the shortcut one. When I have to write so many terms and remove terms, I may lose track. So e to the 5x derivative will give me 5 e to the 5x. Derivative of cosine gives me 1 over 4 sine 4x integral, I'm sorry. And then derivative here is again another 5 will go in front, which is 25 e to the 5x, and then integral of this one will be negative 1 over 16 cosine 4x. And then we stop here, because why I stop here? Because I have started with cosine and I came back to cosine. So this is a complete loop now. Then you have a plus sign here, minus sign here, plus sign here. So what do you do now? multiply this with this and this with this, and then go straight. So then you'll see what happens. Now the whole result will come out like, let me call this is my integral I. So I end up with 1/4 that you have seen already, e to the 5x sine 4x, and then minus will be plus 5/16, and then come out as cosine 4x e to the 5x, cosine 4x, and then goes straight. When you go straight, the plus and minus altogether will be minus, and straight when you go, you need to take integral sign. So 25 and 1/16 will make it 25/16, and then e to the 5x cosine 4x dx. Now you see what happens. This whole integral has come back here with a multiple of 25/16. Then I can say that I have I equals 1/4 e to the 5x sine 4x plus, I don't need this table anymore, plus 5/16 e to the 5x cosine 4x minus 25/16i. Do you see that? This integral sign with e to the 5x cosine 4x is the main integral. So is that. Now this is the term you can move on the left side with a plus sign. So to move with the plus sign, you get I plus 25/16i, which is 1/4 e to the 5x sine 4x plus 5/16 e to the 5x cosine 4x. So then add this one here. What is I plus 25/16i? 25 plus 16, 11, 4, 41. Is that right? 1 plus 25/16, so 16 plus 25. Yeah. So that gives me 1/4. I can just factor out maybe e to the x, or other way you can say 1/16. If you say 1/16 factor out e to the 5x, then you end up here with 4 sine 4x, just writing nice answer, but if you don't factor out 1/16 is still okay, plus 5 cosine 4x, 5 cosine 4x plus a constant. Now this 16 I can cancel. So then final result is 1/41 e to the 5x 4 sine 4x plus 5 cosine 4x plus integral constant. Do you see that?